Hello and welcome to today's session. Today I am joined by David Simmons, Head of Developer Relations for QuestDB, and we are going to take a look at Kubernetes. How are you, David?
I'm great. I love the Sig Seg V there at the end of your countdown. That's awesome.
Yeah, I wanted to do something that is kind of geeky and took inspiration from the IT crowd. I really like their intro and the ending where it kind of Windows crashes and it does that weird traily thing. So,
Yeah,
but I don't have the creative expertise to actually do anything that intricate, but flashing a red banner on the screen, I got that bit down.
you got
So,
that bit. Yeah, I love the IT crowd too. That's fantastic.
oh yeah, it's so funny. So today's session, let's start with a question actually. In a word, what is your knowledge or expertise of Kubernetes?
Well, the word I would choose, I probably don't want to say on a live broadcast, but I. So here's my thing, and this is why I sort of talk to you about doing this. Is I understand the point of Docker for the most part. I don't like using it mostly because the Mac version of Docker will suck the life out of absolutely any machine so far. And so Kubernetes is just like, seems to me to be just extra Docker, and I don't get it. Because I don't mostly, I don't, people say, oh, well, I'm going to run, these 16 Docker containers. Like if I tried to run 16 Docker containers on this laptop, it would die. And it's a brand new Mac laptop. So
Yeah, I like that description. Kubernetes is extra Docker. I think we'll try and build on that today a little bit. But you're right, definitely right about Docker for Mac, where it is the easiest way to kind of have a working Kubernetes control plane on a Mac. The battery consumption is pretty ridiculous. I am very vigilant on closing it now, whenever I definitely do not need it. So that's great. We're starting from essentially a fresh slate, and you're going to keep me right as we kind of go through today's, I guess it's a tutorial of sorts, where I will do stuff with Kubernetes. You're going to probe me with loads of questions. We're going to try and get something working on Kubernetes, and hopefully, I have the ability to explain what the hell I'm doing, which is questionable at best, but we will see how we get on.
that's where the fun part is.
Yeah. So what I would say for the people that are watching on YouTube, feel free to liberally use the comments. If you wish to ask questions, we will make sure that we try and tackle them as we go. So leave comments, we will address them. And I think what I'll do is just share my screen and we'll dive straight in. This maybe seems a bit brave, but there. Awesome. Okay. So this is just the Kubernetes website. What I would say today is I would say rather knowledgeable in Kubernetes. I know what I'm doing, but I have not memorized all of the YAML in the world. So where I am not able to generate the YAML for my VS Code editor, I will be using the documentation, and that is okay. Nobody expects you to remember how to type tens of thousands of different combinations of YAML. We'll just
Uh,
normalize that.
I was just telling somebody that I'm mentoring the number of times I still have to Google, how to do a for loop in whatever given language I happen to be using that day is ridiculous. And I've been coding for 30 years. So don't, don't ever let somebody tell you that you should know all this stuff.
Oh yeah, for sure, definitely. Like the longer you do this, the more you forget, and you always have to kind of look that stuff up. It's
Mm-hmm.
natural. In fact, I think people that are good at this are people that are really good at understanding the problem enough to ask the right question to then go find the answer, rather than just inherently knowing the answer.
Right.
All right, so let's. I just reset my Kubernetes cluster, which is what the screen is here. It's done now. I am going to type a few commands. I don't, and then we'll backtrack a little bit and talk about what Kubernetes is doing. But our main way that we are going to consume Kubernetes today is through the kubectl command line application, which we can run in our terminal. And the first primitive that we're going to cover today is the concept of a pod. So when I run get pods, you'll see that I have nothing. So that's just me doing the whole magician sleeve thing, right? There's nothing pre-running here. This is an empty vanilla generic Docker for Mac Kubernetes cluster. So let's back up a little bit and I'll go back to just our nice little talkie mode. Let's try and break down and understand what we should cover as a backstory or context first. So, containers, the Dockery bit of this conversation. Kubernetes is a control plane for managing and orchestrating containers across one or more machines. If we were to explain a container, then we have to kind of get down into some Linux primitives. So a container is a way of using the Linux kernel to segment certain aspects of the process that is running to protect it from the rest of the host.
Right.
That sounds a little bit more complicated than I maybe intended it to be.
No, the container part makes sense to me, and sort of having something to control all the different containers makes sense to me. But coming from, having grown up in the old world, client server, each sort of server has its own part in this. A lot of what I don't get is how you can spin up extra containers and have the rest of the containers know about what's going on, right? And how this actually helps me, rather than, why don't I just have, a big server that can do this and call it a day?
Hi, doggy.
Yeah.
Okay, so you're comfortable with the container, excellent, and you want to understand some of the magic components of what Kubernetes is doing.
Yes.
So with that, let's go straight into let's go into the Pod 101 then. So let me just make sure this is readable. I have to save it as a file. Okay, so I'm on computer.
It could entirely turn into a live session of me yelling at my dogs, by the way, just so we know.
I'm perfectly comfortable with that. Don't you worry about it. Now, I'm going to just quickly get this to as minimal as I need it to be, and then we'll go through the different components of this. So we can't deploy a container to Kubernetes, really. What we deploy to Kubernetes is a primitive called a pod, and a pod is a collection of one or more containers. So
okay.
with Docker, you can do Docker run nginx, and what that does is it creates Linux namespaces and control groups to kind of wrap that process up in its own little bubble.
Yep.
But Kubernetes doesn't do that. It actually creates the bubble and then puts containers inside of it, and it can have more than one container that share the same resources within that bubble. I mean, I'm not comfortable with that analogy, but it's what I just blurbed out my mouth, so I'm going to stick with it for now.
Okay. That actually makes sense to me, which is either really good or really scary, depending.
Excellent. So we've got a concept of a pod, and we can think of it as a container for now, but it is important to understand that it can be one or more containers, and it's not directly mappable. Now, Kubernetes is all YAML driven. You can use JSON, but that would be a bit cruel. YAML is slightly a bit easier to work with because we have the option of doing comments as well. So when we describe the YAML for any resource in Kubernetes, so this format works for every different type of resource that we're going to work with today. Then generally what we have is an API version and a kind. The API version and kind they're like a key that says this is the object type that we're working with. So, imagine there was a V2 pod and a V1 pod, although that's not the case. These two are directly linked and will very rarely change. We then have the option to pass in some metadata. So, this is just pretty much as it looks. We have the ability to say the name of this pod is going to be nginx, and we can apply some labels to it, which allow us to query those pods using our own selectors from the command line.
Okay.
So while that is important, the start of that, it doesn't actually affect what we run when we apply this to the cluster. To do that, we have something called a spec or a specification, and we have the most important key in a pod is the list of containers that this pod is going to have.
Okay.
Now, we're only going to have one for the time being, but this pod spec here, or this container spec, is very similar to what you would do on the command line with a Docker container run or Docker run command.
Right.
So we can give it a name, we tell it the image that we wish to run, and I'm just going to give this a hint that it exposes a port for us. We're saying nginx has a port 80 that will be available where I can send requests to this container. And that's it. So that means that I can do a kubectl apply. We use the -f flag to say that we want to apply a file, and I can pass in our pod.yaml.
Okay.
And that creates a pod. Now, because I know my muscle memory is going to kick in soon, I'll clarify that I am very likely just to start typing K. It is just an alias for kubectl. Oh, well, no, I've just broken that alias for kubectl. What I meant was that K is alias to kubectl. So I can now run get pods, and what we see here is that we have a pod called nginx, which is what we called it. We can see this ready, but here it says 1 of 1. That means one container was in the spec, and we have one running, and the running status is here. It has not been restarted, and it was created 24 seconds ago.
So
Easy.
when you applied that pod.yaml, it basically started that pod and started it running.
Yes, that is correct. So we can go into the details of how this kind of declarative approach works from the API point of view, or the you know, we can talk about how the controllers within Kubernetes work if you want, or we can keep focusing on the workloady bits. That's entirely up to you.
Let's do the workloady bit, because that's
all right. So we'll just go on the assumption for now, and maybe we'll change that later. But when you apply something to the cluster, something creates it and it works. I'm happy with that assumption for now. Okay, so we have a few introspection commands that become really important when working with our Kubernetes clusters. So, we've seen that we ran get pods, which gets me a list of pods. I can also add a name to that to fetch a single pod, which does nothing differently right now.
right.
But one really important thing when you're working with Kubernetes is that sometimes you'll actually want to get a bit more information. So you can use the -o flag, which just means give me this pod information in YAML, and we can actually see a lot more information about what is going on underneath the hood here. One other option we have is wide, which just gives us, again, a bit more information. So the -o YAML one is slightly more important because it's a really good hacky way of then writing pod2.yaml and then being able to generate fake resources. But we won't cover that just now. Because I'll end up rambling about it. Okay, so that's a pod. One or more containers. We create the YAML. We apply it. One thing is really important about pods is that they are the lowest common denominator, or the primitive, or the atomic unit of what we make run inside Kubernetes. However, what is really important is that this is an immutable pod spec. Pods cannot be changed. So if I were to kind of prove that, let's say I want to do nginx2, or in fact, yeah, let's do that, nginx2, and then I try to reapply. You can see here that the pod nginx is invalid, spec forbidden, pod updates may not change fields other than container image, or active deadline seconds, or tolerations. So you cannot modify anything particularly useful about a pod directly.
Once it's running.
Oh, yes, once it's been applied.
Yeah.
Even if it failed, you still wouldn't be able to modify it. So our only option now would be to delete it. However, I think that there's one more important command here. We applied it, we queried it, we've done a get pods. We can also run a kubectl logs on our pod to pull out that log information if we need to do any sort of debugging to work out why something is crashing.
Okay.
All right, let's delete that. Delete it correctly. All right, and when you issue like a delete command, it will wait until that resource has been cleaned up. So you may find that it just hangs there for a little bit. It's quite normal, nothing to worry about. It goes away. We can then run get pods, and we're back to where we started. Any questions on that little bit of surface area that we've touched so far?
Nobody managed to make the fan spin up on my laptop, so I'm wondering how you did that, because, Docker.
Yeah. Yep, don't worry, mine's just taken off too. So
Okay.
So we don't work with pods. I think that's really important. As important word fuffle there. As important as understanding pods are, and as important as they are, we never work with them directly. We have other abstractions within the Kubernetes API that allows us to work with them in a slightly more manageable fashion.
Okay.
So what I'm going to do is just create a new file and call this deployment.yaml. So when you first, in fact, when you first or even 1,000 days into deploying to Kubernetes, the deployment object is the de facto right now for if you want to take your application and run it on Kubernetes, you use the deployment spec. It is a superset of a pod that comes with a controller that does loads of magic stuff. Magic stuff includes modifying or at least rotating the pods when the spec changes, scaling up, scaling down, handling update strategies, all of that magical mystery stuff that we're going to try and cover. I'm using a VS Code plugin for Kubernetes. That means I do not need to type a lot of YAML for the common resources. So that's why you can see it being templated out like this.
Yep.
And I'm going to use Nginx as a base for most of the stuff we deploy today, because I think we're all familiar with it. We know what it is, and there's no magic there. I am going to continue to remove this resources block. In fact, I'll do it one more time to show why it's kind of there. You can see all the squiggles I get. That is my editor telling me that you should not apply a Kubernetes resource without resource management because it could eat up all your resources. So I can kind of silence that to one line while pushing an empty block. And you'll see there's a couple of things different from this, but still very, very similar to what we kind of played with the pod. So you can see that our object key, the combination of API version and kind, has changed.
Mm-hmm.
The fact that this has changed from v1 to apps just means that we've dropped out of the core namespace, which is where the pod lives, and we're now into an application-specific namespace, which is handled by a different SIG. The working groups and SIGs of the Kubernetes project all handle different API touchpoints. The object that we're now deploying with is called a deployment, and it still has some metadata that we can apply to it. We still want to be able to name the object that we put in the cluster.
Okay.
Now, this bit here, this pod and container spec has not changed. It's just slightly deeper in the YAML structure. And what we have here is the actual deployment spec, and the bottom bit is the pod spec within the deployment spec. So when we create a deployment, we're saying we want to deploy this pod, but we have some information that surrounds it or encapsulates it that is really important. And the most important thing with the deployment is something called labels and selectors. Now, I think it might be best to apply this first and then double back on the selectors when we have something running that we can maybe take a look at.
Okay.
Okay, so we applied that just like we did the pod, only this time, it's got a different prefix before it. It doesn't say pod, and we can run get deployments, and we see something very similar to what we had with our pod spec.
Yep.
So we have the name. We've still got one of one containers. Now we don't have something called a status. We've got up to date and available, and we'll talk about why this spec is a little bit different. But what's important is if we run get pods, you'll find that it does still create a pod for us. It's just now a managed pod.
Right. So it's got the ugly string on the end of it because it's managed by something else, right?
Yes. So this is a 3-piece tuple, and each segment in this tuple identifies a different layer of abstraction. So let me try and explain how the deployment actually works. When you create a deployment, it gets created in the cluster and nothing happens. There is a deployment controller that notices that object, and then it creates something called a replica set. Get replica sets. And you can see they've now got a 2-piece tuple.
Yeah.
So this is the deployment name, and then this is the identifier for the replica set. And then there's a controller that monitors the replica sets and goes, oh, we need pods. And then this is the pod ID. So we got this layer of command. So
Right.
deployment creates replica sets create pods, and we create the deployments. Now, it's very confusing. It can be a little bit difficult to understand. And it's just to do with the way that Kubernetes works and its controller model, and people, the controls are only responsible for one really small part of the API. So disregard that unless you really want to know about it. We can talk about it later. What we really care about is we created a deployment and we get a pod out the other side. So if we just pretend our view here is get deployments and pods, you can just do a get with a comma and it'll pull out multiple types.
Okay.
So you can see we've got our deployment, we have our pod.
Yep.
Okay, next. Labels and selectors. So because I've already, it's good now that I covered that hierarchy of abstraction. The deployment controller needs a way to know which replica sets it created. The replica set controller needs a way to know which pods it created. So that if I delete the replica set, it deletes the pod. And if I delete the deployment, it deletes the replica sets. These labels are used to do that matching. At least they form a base of the matching. So if I do a describe on deployment nginx, let's see. You can see that this has a selector that says all of the replica sets. And it doesn't say here replica sets, but because we've kind of covered that hierarchy, we know any replica set that says app equals nginx is going to be controlled somehow by this resource. I can then do a describe on the replica set. Excuse me. And we should see our label as app equals nginx.
Yep.
And of course, if I do a describe all the way down the tree, we're going to see labels app equals nginx. So these labels are a way to identify how the different layers of abstractions are actually owned or controlled or operated, etc. Does that make sense?
Yes, it does.
Awesome. Good. Now, because this is a deployment, we can modify anything we want. So let's keep the name the same. Let's not confuse the poor Kubernetes. And let's do app nginx tutorial. Now, these do need to match up. Otherwise, we're going to have a mismatch in the selector. So if I say this and I try and apply this, it should hopefully complain. Yeah. So these do always have to match. Otherwise, you'll have resources that were created that were not operated by their controller.
Right.
And we can modify the containers. So say that I don't want to run nginx. What about if I want to run HTTPD? So I'm going to change that image and I'll change the name of the container. And while I'm here, just for good measure, there are many other fields on the deployment spec that we can change. The most important one is the replicas. What if I want to scale this deployment? I can set the replicas to 5. And if I apply this, I broke it.
You changed the name.
So yeah, these bits are immutable because I'd already created the deployment. So I'll cheat and just modify the name to create a new resource. And I will delete the old deployment like so. And we'll pretend that it all worked. So deployments, we now have this new one, and you can see that we're starting to scale up. So we have 2 available out of 5, 5 available out of 5. So pretty quick. It didn't take a lot of effort to scale this service. You can imagine if this was a production thing and I wanted to be able to scale on demand or in reaction to metrics or whatever, it's as simple as modifying my YAML and saying, I need more of these, please.
So you can modify the scale of it at runtime, basically, right? You can add more or remove them, and it will scale appropriately.
That is correct. So let's assume we come in here and we're like, oh, right, we've weathered the storm, whatever magic event happened on Twitter, we now can, maybe comfortably go back down to just having 2 replicas. We just reapply our deployment.yaml. I'm going to run a get pods with -w, which just means watch, and I was too slow. I mean, it's already scaled that resource down for me. So
Yeah.
so yeah, we can modify the spec. And this just comes down to the way that Kubernetes works. Whenever you apply anything to the cluster, those controllers sit in the background and monitor the spec. Whenever that spec changes, it goes out of its way to do a reconciliation loop and get the cluster into the state that we declaratively define.
Which explains why you can't really change the name in the on a running cluster, because then it would not understand what it's supposed to change, and it would cause all sorts of mayhem.
That's a good point. I hadn't actually thought about that. Changing the selector on an existing deployment would actually put you in a moment of flux where it didn't know which resources to clean up or create. So that makes sense. There are some lettered immutable fields across it. You'll hit them at one point or another, and if you're anything like me, you'll forget. But we can use this deployment spec now as a basis for most workloads that we want to deploy to our cluster.
Okay.
Any questions on that, or are we happy?
No, we're happy, and we can add other services to that pod by just adding more containers to the pod. Is that the idea, or now I'm really going to confuse it?
No. So there are use cases. So this is a really common pattern in Kubernetes called sidecar. Sidecar is generally a name that we use for any pod that has multiple containers. Something that you may wish to do, and a bit of software that we were both familiar with, would be deploying Telegraph. So assuming we wanted to do have a sidecar container, a Telegraph container running next to our application and scraping metrics in a Prometheus-based pool style operation, then we could add a container like so, and then I can just reapply this. And what we're going to see here is our new one here has ready 0 of 2. Now that just means that it's currently pulling the Telegraph image.
Yep.
I can run a watch on this with -w and it will work this time. And we'll see that change as the image pulls. It's now spinning up the pods. So it's now killing the old pods. So, it spun up the new one first, waited until it was almost running, started to turn down the old one, and then the other one gets terminated. What we can do now is run get pods, and you see that we have 2 pods, each with 2 pods, both running and happy. So this is a pattern that is used to enrich or augment the functionality of a container or application with some other piece of functionality. However, you would not use this pattern to deploy every service in your application as a single deployment. What you would do is have multiple deployments. So let's add something then to this. Let's add a new file, and we'll call this our deployment 2, very unique and original name.
Yeah.
What image should we deploy? We can just deploy Nginx again. But we'll give it a name that's not Nginx. We'll just pretend. Because that image is already in my cluster. I don't need to pull anything new, which is probably a good thing. So let's pretend this is some stateful database application, Oracle DB, because, why not? We'll call our selectors. We'll just make this match as well, so we don't have any conflicts. But we're still just going to deploy Nginx, and I'm going to continue to pretend it's Oracle. And I'm not going to expose any ports. In fact, we will, because we're going to show off some of the networking functionality that we get with Kubernetes.
Okay.
So this is our second deployment. It's Oracle DB, and we can apply it in the same fashion. We run get deployments and pods. And you can see that we now have 2 deployments. We have our Nginx tutorial, we have Oracle DB,
right,
and we have our collection of pods.
Yep.
Okay, now we want this stuff to talk to each other.
We do, and I always have a hard time with this with Docker containers, because it's like, well, that's running in a Docker container. You can't talk to it. I want to talk to it.
All right, let's see if we can make that happen then. So the primitives we've covered thus far are pods and deployments. There is another really important one called a service. And a service provides a DNS-based discovery of the other services within our Kubernetes cluster. So it's called a service.yaml. And we have autocomplete, which makes my life a lot easier. So we'll expose our Nginx one, and we'll make it available on port 80. We don't need to specify a target port as long as I'm not getting this wrong in my brain. The target port will default to the port. So what this YAML says is I want a service to exist called Nginx. That name will be created as a DNS resolution within the cluster, so I can then query Nginx as if it were a URL. The selector is the same as what we had in our deployments. The selector says all of the pods that have this label app Nginx, we will allow to answer requests for the Nginx service.
Okay.
So this could also, based on our current examples, be Oracle DB.
Okay.
And we have to tell it which port. So we can publish services on any port that we want, port 80, port 443, port 53, whatever. And because this is a web service, I'm going to export it on port 80. And we can apply. Like so. Now, what command do you think we run to list the services?
Probably get services.
Yeah, it's not a trick question. That's what I guess is nice. The entire Kubernetes API surface is mostly just a RESTful API, and then the commands that we use to query that become very intuitive very quickly. So what we can see here is that we have an Nginx service of type cluster IP. Cluster IP just means that it's going to generate an IP within the service IP range for the cluster. And you can see here we get a 10.105.193.142.
Right. Right.
Not exported externally. And the port that we defined is also there. So if we want to see this working, we can go inside of a pod. So very much like Docker exec, we have the ability to do kube control exec. And I'll jump inside this Oracle DB container. And I have a bash shell here.
Right.
Do I have curl? I do have curl. Excellent. That makes my life a little bit easier. So I can do curl http nginx. No, I can't. All right, we may have our first problem. The labels were wrong. Okay, so now we're into debugging a service.
Okay.
Because when I created this deployment, I updated these selectors with the new ones. So my selector on the service, if I split the screen here.
Yep, is Nginx and not Nginx tutorial.
Exactly. Now, the way you debug this in Kubernetes is to describe our service. Now, what's important here is our endpoints are none. This is the first indicator that the service you've created, you've made a mess of it.
There's no endpoint to the service.
Exactly. So I'm never going to be able to query it. So we can fix that with tutorial. We reapply our service, and before I even query it, I'm just going to describe this thing again, and right away we've got two endpoints that are happy to answer that question of, can I speak to Nginx? So you can see here.
Yep.
All right, so let's try that exec again. Is my curl there? Yep. And you can see if I curl Nginx, the service name, I get a response from our Nginx deployment pods.
Great.
And that works ubiquitously across your Kubernetes cluster. So why don't we tackle the very explicit DNS name that happens here? Now, it's not that Nginx is a valid domain name. What is actually happening here is that it's being completed by the DNS within the cluster to svc.cluster.local, like so. And this is a predetermined format that works in almost every Kubernetes cluster. So this is the service name, Nginx. Then we get dot, followed by the namespace, which I know we've not covered yet. Followed by the resource type. So SVC is just short for service. And then this cluster.local is the cluster domain name. Now, most clusters ship with cluster.local. I think it's rare that I see this changed. However, I guess it is important to know that it's not going to be there 100% of the time. Whoever spins up the Kubernetes cluster can pick anything they want. You could
Okay.
have david.lolcat or something. So, and because of the way the DNS resolution works, I can query that at each level. This is something in DNS resolution called ndots, and it's configured within the cluster. So you get a lot of flexibility with service discovery. Now, something else that is really cool about this, because it's not cool enough that you get DNS-based resolution, you also get rounds robin load balancing.
So it's also doing a load balancer as well as because I saw that it when you did the describe the service, it had 2 endpoints, so it will basically load balance between those 2 endpoints.
That is correct. Now let's visualize that. Let's modify our image here. So this is an image that exists on the public Docker registry.
Okay.
It is from the Functions as a Service project, OpenFAS. And the node info name just means that this container will respond with whatever the host name is called. Now, because of Kubernetes networking, the host name is the pod name. You can see here in the Oracle one that this is the name of my pod. So if I reapply our deployment 1, we should see those all will be rotating. Yep, so the first one's on its way. Let's just watch. It's pulling that functions node info. Now it's replacing the other 2. We just got one more to go. All right, we're good. So these 2 pods here are running the node info. Oh, don't break. Okay, the node info image. So I'm going to jump back into Oracle and just run this again. So we're going to see different output. This is no longer going to be the output from Nginx or Apache Web Server. That was unexpected. The port is changed. I never thought of that. Okay, so this port is actually 8080 in that container.
Okay.
So now we need the target port. So I'm still going to expose it on port 80. I don't want to change my curl command here. Right. I want it to work like that. So now the target port and the port are actually different. So we just specify it like so. So now I need to reapply our deployment.yaml and our service, and we can do that in one liner with 2 -f flags.
Okay.
We shouldn't actually need to wait. That should all restart pretty quickly. Quicker than that. Come on. I guess the shutdown is actually what's making it take a little bit longer than I thought it would. I'll be patient. I'm very patient. Okay, so we've got 2 new ones running. The old one's shutting down. That's okay, but we have these 2 which are 20 seconds old. So we go back into Oracle DB, and we can hopefully curl Nginx. Perfect.
Yep, and it gives you the host name. Yeah.
So now we have the host name, the platform, the architecture, how many CPUs are available, and the uptime. And if I hit this more than once, there we go. You see the host name changed on the 3rd try. Now we've only got 2 pods, so it did take a couple of tries, but you can see we are getting load balancing across those service endpoints. So another really cool kind of quality of life thing that you get for free that used to be really difficult, or configure an HA proxy to do the load balancing for you can be a little bit cumbersome. So this is nice, right?
Yeah. So my question about all of this is, how much overhead am I adding with all of this? I know that, Docker, at least on Docker Mac, is just a resource pig. So am I adding a ton of overhead to whatever I'm doing, just to get this little bit of niceness?
Yeah, I mean, it's not. There is a cost. It's not free, of course. There are not many. There are a few components that need to be running on the bare metal for this to work. Now, Docker for Mac is a slightly unique situation in that because Mac doesn't understand container primitives directly, Docker for Mac does run a virtual machine. And that
Right.
virtual machine running is going to be a battery sync. So let's just talk about maybe the bare metal experience rather than the Docker for Mac one, because I think that's just something we have to live with if we run Macs. So on a bare metal environment, the overhead for running containers with Kubernetes will be there is a kubelet process on the machine, which is responsible for starting, stopping, and handling the containers. There is a kube proxy or a CNI implementation. So there is some sort of networking on the machine that actually knows how to do all the IP table manipulation. So there's a cost there. There is also across the cluster, but not across every node, there is API servers, schedulers, and etcd. Oh, and DNS. So there's those 4 control plane components which have to be scheduled somewhere, if not on all the worker nodes. Well, probably not on all the worker nodes, but they have to be scheduled somewhere and highly available. So there is a cost. It's actually not too bad considering the things you get for free. Because if you were going to do this manually, I mean, besides all the automation you would have to write to dynamically reconfigure HA proxy as services come and go, this is probably a little bit cheaper, but with the painful point of, well, shit, you need to learn all this stuff now. So, choose your battle.
Yeah. Yep.
Okay, so we covered pods, we covered deployments, we have covered discovery and load balancing across pods with services. Now we've only looked at one service type, which was the cluster IP. That is the default. That is why there's nothing in my YAML that says this is cluster IP, but you can pretend that we had this line here. So that is just the default. There are other service types. I don't think they're going to be particularly important for today. They are typically used to expose services from the cluster outside of the cluster. Okay, how about configuration? So what do we have running right now? Okay, let's do this. Let's change our functions as a service back to Nginx. Oh, that's a good point. We could do that too. Okay. Sorry, too many ideas. I'll leave Telegraph in. We change this port back. And we'll leave all of that as is. So really all I want to do right now is get our Nginx back to normal. We'll give that a few seconds. So,
okay.
What we're going to do now is we want to inject some arbitrary information into this Nginx pod so that we can change the behavior. Right now, responding with the Nginx hello worldy style page or basic default page isn't terribly useful. So we want to see how we can pass in some sort of configuration to change that behavior. We may even just do that to configure Telegraph to probe Nginx or something like that. But we want to show how we can configure the processes running within our pods.
Okay.
Now to do that, we need a new resource type. So let's call this configmap.yaml. ConfigMap. And we'll call this Nginx. Now, config maps are YAML definitions of key value pairs that live inside of our cluster. So I could have username Rawkode. I could have index.html and use YAML's multi-line thingy-majiggy to say hello. I am Rawkode. And if I want, I could do some sort of list. So I could do numbers 1, 2, 3. Why is this yelling at me? It is a string. Why am I failing at YAML?
Because it's YAML.
Every time I think there's nothing wrong with my YAML, I'm always proven wrong. So the YAML linter is my friend. My YAML is fine.
Mm.
Okay. I'm just going to assume it's wrong, and VS Code is just a little bit confused. So let's apply our config map. Type got an array. Okay. Yeah, it's right. I'm wrong. Config map key value pairs cannot have subtypes. So let's just do numbers like this. Just me being silly. Okay, so we can apply that. And now we have something called a configuration map available inside of our cluster. We can do get config maps. We see Nginx. We can query Nginx. We can use the output toggle that we were using earlier. And we can see our data is now stored here inside of our config map.
Okay.
That is now in a position where we can consume this within our pods and deployments and inject it inside of the containers. And there are two ways we can do this. So let's open this. What should we do first? Let's do exposing these as environment variables. So we can do env from config map reference. Give it the name of Nginx. So these three lines here tell our deployment that there is a config map called Nginx that we want to expose as environment variables within the container.
Okay.
I can reapply my deployment. And what we will do is just exec into one of those pods. Oh, that was just restarted. Let's try again. Oh, there's two pods. Yeah, so sorry, there's two containers. You need to specify the container name when there are two. So -c nginx and then run bash. I was getting confused about which one I wanted to run in. And that pod is away because that's the one that... Oh. I should just wait until all the pods have restarted before I start trying to get inside of them, shouldn't I? All right. So this ID is changed. So let's do this. Okay. So now we've got a proper pod name. We tell it which container and we want to run bash. Finally.
There you go.
We can run the env command and we'll see here index.html equals hello, I am Rawkode. We have numbers equals numbers and username equals Rawkode. So now I have a way to dynamically configure my application as long as it understands environment variables.
So for things like if you were, for instance, running a database that had that you had to pass in a key for inserts, you could run, and it can get that from an environment variable. You pass it in there, and then all of the various pods pick up that value, right?
That is correct. Yes. Now we have another option. If we don't want, if our application cannot be configured through environment variables, we have the ability to use a volume. So in our deployment spec here, we can say volumes. We'll call this config. The volume can come from somewhere. So we can say here that it is a config map with the name Nginx. So this says define a volume called config with the contents of the config map Nginx.
Okay.
Now that doesn't do anything on its own. We then have to mount the volume into the container that we want to have it. So here we can do volume mounts, mount path, I'll call it config. and the volume that we wish to mount is
It's
config.
config. Yeah.
Okay. So now we can come back over here. I love that when you just do one of these introduction to Kubernetes things, it's just, hey, look at all of this YAML.
Yeah.
I'm really sorry.
No, and I
But
don't know whether it's really scary but it's actually starting to make sense. So that should probably scare people that are watching this because it's actually starting to make sense to me.
well, that's good. I'm glad that I'm not just bombarding you with YAML. Okay, so we're going to go back inside one of our new pods, not one of our old pods. And just so I don't hit the old one, I will copy and paste. We specify the container and we specify the command. So we still have our environment variables here.
Yep.
However, we should now have this config directory
Yep.
where I can cat each of those values like so. I know that's a little bit difficult to see because it kind of happened in line, but you know,
Yep.
there's a Rawkode at the start of that and the numbers here
Yep.
and our multi-line string there. So those are that's how we configure our pods with non-secret information. There is something very similar to a config map called a secret, which is kind of secret, but not completely secret.
Okay.
So, let's
So we're calling it secret, but it's not really secret.
yes, unfortunately. Okay. So what I'm going to do is YAML allows us to do 3 dashes to split one document into multiple types. I'm just going to use that here. I'm going to copy the config map, paste it, and I'm just going to change this to be secret. I'm going to change this to be string data. I think that's enough. We'll see. So let's reapply our config map, and we should expect to see a secret created like so. So why does my screen share keep tearing like that? There we go. I am running Mac Big Sur, so you know.
You're inside your container there, so that's probably not going to work.
Good catch. Thank you.
Yeah.
All right. So cool. So we reapplied that. Now you can see our config map is unchanged. We didn't modify it. However, we did create a secret now.
Yep.
We can run get secrets. You can see our Nginx one is here. I'm going to pull out that one secret, pass in the negotiation. So I say, hey, give me it back in YAML. And we have our secrets.
Uh-huh.
Do those strings look secret?
Not particularly.
No, this is our wonderful favorite encoding, base 64. So secrets are not terribly secret. There are things and stuff one can do as a Kubernetes operator to improve the situation, but by default, our secrets are available to anyone with permission to query them. They're just obfuscated through base 64. And that is why we also specified string data in this file.
It's better than ROT 13, I guess, but
but whenever you see that equals sign, you immediately know I'm just going to base decode that and I've got
right.
access to whatever. But yeah, this string data, if I had not changed that to string data, if I had stuck with data, this would have failed because it's not base 64 encoded. It would have said, hey, those values don't look encoded to the way I want. So you can pass them in as string data. Of course, when it comes to secret management, there's a whole world of tooling and other options with Kubernetes, but this is what is baked in and built in for free. The good news is, like, you still need authentication to the Kubernetes API. You still need a kubectl that lets you do the query. Things are encrypted on the node machines at rest, and in transit. So there's that plus. But if you ever get access to the cluster with this fashion, then your secrets are compromised immediately. So,
well, physical access is game over for most things. So in security land, so
that is true. All right. So Any questions before we start tackling a few other bits and pieces?
No, this is great. I'm actually learning stuff, and this is making sense. So,
All right. So when we spoke about the service DNS lookup earlier, we mentioned something called a namespace. So we'll just really, really quickly cover what that is. I don't want to spend too much more time on it. So I don't want to spend any time on namespaces because they're super uninteresting, but
okay.
they're important to know. So namespace YAML. We have an
Oh, yeah.
API. Yeah. We have kind. And this is the only one I can ever remember how to type. So, yeah. Ta-da! I bet you that doesn't apply now, but... oh, metadata. Silly me. I was right, it didn't apply. So, namespaces are in the core V1 group, which is why it's just V1, the kind is namespace. The namespace is called my namespace. Much like every other object, I can tell get namespaces, and we have our new namespace. Now,
Yep.
everything that we have created thus far has been created in the default namespace. I can run get pods, and I see stuff and things.
Yep.
If I do get pods -n my namespace, no stuff and things.
Oh.
But namespaces are a way to logically group things depending on your own workloads, configuration, setup, team dynamics, Conway's law, whatever you wish to apply to that logical grouping is entirely up to you. But namespaces are a way to encapsulate that altogether. What is funny though is you can. Oh, you can't delete the name. Yeah. You can delete the namespace and it will blow away all of the resources. There's nothing in my namespace, but it would have destroyed everything. I didn't realize default was protected.
Does it, so what, when you say it destroys everything, that destroys the pods and everything in it, or just the namespace around it?
No, it should destroy all of the pods. So if we do, well, let's just reapply this then. So let's copy this deployment. I mean, if I remember correctly, it doesn't really care. So we can specify the namespace in our metadata, and I can say deploy to my namespace, like so. We'll reapply our my namespace with the deployment. We run get pods my namespace. I'll at least let them be healthy before I try and kill them. So I actually think I've ran out of resources. So let's debug that. The reason I think these are stuck in container creating is if I describe the pod, I think it's going to tell me that it can't allocate the resources. Namespace. Oh no, it's the config map. Okay.
Oh, you're trying to mount the config map from two different places.
That is correct. So I'm just going to copy in everything just so that this applies. Update the metadata. I don't even think we did anything with the secret, but I'll create it anyway. We'll apply that once more. We'll run get pods. And yeah, so there's this also weird thing where that pod is now stuck waiting for something that didn't exist. So you kind of have to give it a wee shuggle.
Give it a what? I need to hear that again.
A wee shuggle.
Okay. Outstanding.
And just give it a wee shuggle and then it'll restart or so. You just delete it, it comes back. Is it still going to fail? Did I update all the right stuff? I think I did. Ah, there we go. Just me being impatient again. So that's now running. If we look inside our my namespace again and we call get secrets, we'll see our secrets, we'll see our config map. Like that's all what we expect. And then we'll just delete my namespace. And it's away. It's now currently deleting that secret, that config map, that deployment, that replica set, and those two pods. So, careful with deleting namespaces.
I was going to say, so deleting namespaces can be extremely destructive.
It can be. There's a concept in Kubernetes called a validating webhook. What you'll find is most production clusters won't allow you to issue a delete against a namespace anyway because of the validating webhook. They'll be like, hey, are you really sure you want to be doing this? So, all right. So we've covered pods, deployments, config maps, services, and namespaces. What else is fun?
Who was it the other day that posted that they took out the entire web service for some application for the entire country of Norway because YAML and misinterpreted the word no in their YAML file?
That's one of my biggest gripes with YAML is its ability to take Boolean logic from anywhere it wants. No's, yes, true, false, 0, 1. It's infuriating.
Yeah.
But I hadn't read that story. You'll need to share that with me. Now, I'm sure I'm forgetting stuff. We'll call it pressure. However, I do have a workshop that I've given before, and I'm going to see what I would cover in that. So we did pods. We didn't do port forwarding, so we can take a look at that. We did deployments.
We did a little bit of port forwarding when you pushed one port to, you exposed one port as a 80 mapped to 8080.
Yeah, that is true. You're right. So, the big nasty world of RBAC. Don't know if I want to touch that on the stream. All right, so let's see. Let's come back to our configuration here. So we have this deployment.yaml. Let's spin this back up again. Yeah, let's do that, and then we'll do something with that Telegraph container so we can see the cool perks from having multiple container pods and why they're useful. So, in fact, we still have that running, don't we? Cool.
Yes, that's still running.
So there's a command we can use on the command line, go figure, called port forwards, where we can specify the name of a pod followed by a host container port tuple. So on the left-hand side of this colon, we say this is the host port we want to expose this pod on, and we want to forward traffic to the container port 80.
Okay.
And that's really good for wanting to actually hit your application from your own machine. So I can just fire open a browser now.
Yep.
Go to localhost on port 8080, and it pushes me through to the container port 80 where Nginx is greeting me with its welcome hello worldy style page.
Yep.
All right. So let's try and do something with this Telegraph now. Now, one of the coolest things about containers within a pod is that they share the same TCP stack. What does that mean? Right. Let's go inside Nginx. Only I'm not going to end Nginx. I'm going to go in the Telegraph container, and I'm going to run bash. I don't think I'll have PS. Oh, I do. Okay. So we can see here we have PID1, which is Telegraph, doing this telegraphy thing, and then my two processes here.
Yep.
There is no Nginx running in this container. However, if I do a curl on localhost, we do get Nginx back. So this is to do with the containers within the pod sharing the same TCP stack. Meaning that they both respond on localhost, provided they don't try to open the same port, otherwise things will start to break. So the reason I like this sidecar pattern is that Telegraph, in theory, could be configured to fetch metrics from Nginx on localhost without, because this doesn't actually go over a TCP stack. It's using the networking within the container, so there's no overhead of opening a TCP socket and blah blah blah. It's a lot simpler than that. So in theory, we could create a config map which tells Telegraph to use the Nginx plugin on localhost and go and fetch the status page from Nginx, and then spit out metrics to somewhere. There's quite a lot of benefit there. Okay. Let's cover one more primitive of Kubernetes, and we'll see if there are any questions, and then I think we will be done. Maybe. We do have a comment from Rick Brown, a former colleague of David and I's. He has sworn at YAML for years. It still doesn't make sense. YAML is the devil we're stuck with, not the one we have to enjoy, unfortunately. I don't think I've ever spoken to anyone who's been like, yay, Kubernetes, I get to write more YAML. YAML fatigue is real.
Yes, it is. And pretty much everything these days is now turning to YAML.
Yeah, that's what I'm saying. YAML. Okay, so the last primitive I think is important for today. I mean, we've covered a large chunk. Like, see if I were to say your average Kubernetes consumer or developer, the API touch points that they're going to use within the cluster is 95% deployments with a sprinkling or a dash of config maps and secrets. And that's it. There's not really much more to go into there. Now, there are a few things on the deployment we can dig into with regards to liveness probes. We can maybe cover that. But there is one more primitive here that is useful. And that is a daemon set. So I'm going to deploy Telegraph. Now, we don't need replicas, and there's a reason for that. We do still need our selectors. Let's remove that. I'll get this to a stage where I think there's a slim hope that it'll work, and then we can go through it. I'm not confident, of course. So, all right. I can't remember the API version. It may be apps v1 or it may just be v1. We'll find out through trial and error and fire. We do not need a replica because a daemon set deploys one instance of the spec on every node within a cluster.
Okay. That makes sense.
Replicas is futile. When I say nodes in the clusters, we can run get nodes. This is Docker for desktop, so I only have one node. So this should run one Telegraph DS, which is a Telegraph image with no configuration. Assuming the API version is right, which it is. Perfect.
Well done.
So now I can run get pods, and you see you have this. So the parent object is different. It's no longer a deployment, but it still has a similar level of abstraction to the point where eventually a pod is created. However, we can run get DaemonSets, and we can see here that we have one desired because we have one node and we have one available. So a daemon set is the kind of process you would run. Telegraph is a really good example because you probably want to get hardware metrics or bare metal metrics, node-based metrics from every machine in the cluster, CPU, memory, file size, all that kind of stuff. And a daemon set would be the definitive way to do that in the Kubernetes world.
So maybe I'm getting this wrong, but it seems that a daemon set is basically like run this daemon on each container in the cluster, right?
Exactly. I run this container on every node in the cluster.
Right. Okay. Yeah.
Yes. Okay, cool. So I don't think there's much more to cover in today's session. I think I'm happy with that.
I am actually. I learned a ton. This has been great. I'm hoping it was useful for somebody that was watching as well than, watching me be dumb, which is entertaining in and of itself, I'm sure. But
yeah, I mean, I think what I'll kind of caveat this session with, in that this is not you've learned everything there is to know about Kubernetes, because obviously the details and the intricate nature of some of the components goes much deeper than this. But this is, if you were to start developing against Kubernetes tomorrow, this would be enough to get you working and not banging your head off of too many walls.
Right.
Just working with deployments, config maps. I mean, that is most of the thing you're doing. Now, there are things we could get into. We could talk about Helm Package Manager in Kubernetes for deploying third-party applications, not your own code to Kubernetes. Then there's a whole other world of stuff we could cover there. There's then the day one and day two stuff. There's security, performance, management, RBAC. Like there's so much stuff, but
because
I don't want to overwhelm.
I did notice that all that stuff was running as root, which is probably not such a great idea if you don't have to run it as root.
Yeah, so all of the containers are running by root, which is not ideal. There's things like security to context and seccomp we could get into. Not only that, but every Kubernetes command I've run is as a cluster admin of this cluster. I'm not taking advantage of leveraging the role-based access control within Kubernetes to restrict my access. So I cannot delete a namespace with every resource in the world under it. So although this was never meant to be a guide to everything Kubernetes. This is the Newcomers guide to Kubernetes to get people and yourself comfortable enough to deploy those primitives that you use day in and day out. And I think what we've covered is a really good representation of those challenges and our tasks. So.
This is great. This has been awesome.
All right. Do you have any final questions before I let you get back to your day?
Not that I can think of. This has been super fun.
All right. Well, thank you very much for taking the time out of your day and joining me and letting me just throw loads and loads of YAML at you. I know it must have been extremely uncomfortable, but I do appreciate your time. And it was a pleasure.
Yeah, it was a pleasure. No, I learned a lot. Thank you. Thanks for taking the time.
Cheers, David. I will speak to you soon. Have a good day, everyone.
Bye.
Bye.